Okay, today, by the end of the hour, I want you to refresh your memory on how to find sequences. So everybody take your graphing calculator, hit the Y equals button, see if it goes into sequence mode. And if it does, you're good. And if it doesn't, you need to go to mode and get it into sequence mode. So I'm going to refresh your memory on how sequences work, and then we're going to find something called the long run value. If something keeps going up and up and up and up and just keeps going up forever, then in the long run, do you get that it would get to infinity? Yeah. What if something's going down? There's two things that could happen if it's going down. In the long run, it might be 0. Very good. Or, what's the other option? Negative infinity. Very good. There's a difference. Why would something only go down to 0? Well, what if you had like $1 million and then you took half of it away? And then you took half of that away. And then you took half of that away. Do you get how you'd never go negative? What's the smallest you'd ever get to, theoretically? Well, $1, you'd cut that in half. 50 cents. And eventually it's going to get to some really, really small number. I want you to understand what that means. If you have a long run and you look on your table on the calculator and you go to like the 100th term or the 1000th term, you can get an idea of what it is. But what if the calculator says like this, 1.037 EE12? Do you know what that means? That means 1.037 times 10 to the 12th. That means 1.037, but you move the decimal over 12 spots. Do you get that that's a really huge number? Okay, so when it says something like this, do you get that that's getting closer and closer to infinity? All right, what if it had EE negative 12? The number is not negative. It moves the decimal the opposite way, and it gets really, really close to 0 because it's like this. 1037. You get the idea? On your calculator, if you see this, you have to understand what it means. If it says negative, that means teeny, teeny, tiny, teeny, tiny. All right. That's long run. Long run values are usually either negative infinity, positive infinity, or 0, but there's one special kind called shifted geometric, where in the long run, if you were to graph it, it might go like this and start going up, but then slow down and then level off at a certain number, and it stays that number. It's kind of cool. It can happen. I'll give you an example. Let's say that you're putting chlorine in your pool. Do you get that when you put chlorine in your pool that it doesn't just stay at the same level of chlorine forever? Otherwise, you'd only have to put it in once and you were done. But the reality is you have to keep putting it in. Why? Because the sunlight actually burns it off. But don't you want it to stay at a certain level? Yeah, you don't want too much chlorine, or if you've ever been in a pool like that, it can actually change your hair like to orange. And if you have too little chlorine in it, it's not healthy because like there can be germs in there that can get you sick. So you want just the right level of chlorine. You want it to do something like this. That's an example of a shifted geometric. Shifted geometric. All right. So you're going to learn about that on this sheet that I'm going to hand you. And I know some of you are going to be able to figure this part out, the long run value, without a calculator. I'm going to see if you can discover that today. And if you don't discover it, that's okay. Some of you will figure it out, and that's awesome. And some of you won't, and that's awesome too, because it gives me something to write about. And then I'm going to move on to, on Thursday or on Wednesday when I come back, I will give you a second chance to understand this, and then if you still aren't getting it, I'll help you understand how to do it without the calculator. All right. This is a typical sequence. Would you put it into your calculator? It starts at 20. Remember, the first line of your calculator, it's not 20. The first line of your calculator is actually the 0. You know, it says U0 equals 20. So the top line of your calculator looks like this and says n min equals 0. And then you have u sub n minus 1. Remember all that? Sub is in parentheses. And then the third line is where it says 20. Now, if I were going to ask you what the first term was, that'd be pretty easy. I'd go to the table. And the first term, the 0 term is different than the u sub 1 term. The u sub 1 term would be 24. The u sub 2 term would be 28.8. Do you get how this is going up, up, up? Do you suspect that this one's going to level off at like 100 or something? How could you tell? You go look at the long run. So I go to second table. Oh, I was already on the table, I'm sorry. And then I just basically go down, and maybe I want to even check like the 50th spot in the table. Is there a faster way to do that? Table settings. I go to table settings and say 50. And I look way out there on the table. Oops, that's the graph. That graph tells the story too, but it takes a long time to get your graph set up right to graph these things. I'm going to have it calculate out the 50th spot on the table. You see anything that it's leveling off at? So what's this guy's long run value? A million? It's going to stop at a million, is that what you're saying? In the long run means if you go to the infinitieth term, u sub infinity. In fact, that's what it looks like. When we say what's the long run, it looks like this. U sub, not u sub 1 or u sub 10, it's u sub infinity. So what's the answer for this one? Infinity. Because this is going to keep going up. All right, some of them go down, some of them level off at 0, and some of them will level off at a number like 25. And that's the more challenging kind. All right, last thing, I want to give you a quick review because your homework for tonight, after you're done with the worksheet we do in class, your homework for tonight is about loan problems. And I wanted to remind you, this would be like a $1,000 loan. That is a very common school loan. The average amount of school loans people have when they're done with college right now, is $25,000 approximately. That's how much they owe from going to college. That's on average. Does that mean everybody's most that they have is 25? No. That means there's a lot of people with 50 or even 100,000 in school loans. Did you know the average lawyer right now has $100,000 in loans when they come out? That means that they have, it's like they already owe the entire value of a house. That's a lot in loans. But anyway, this one would be 3%. And what's that minus 100 doing? That's how much you're paying what? Back. You're paying it back annually. Very good. What if this was divided by 12 right here, like /12? That would mean it's all monthly, right? And that means this is also $100 a month. Most loans are like that. Most loans are monthly. Not many loans you pay off once a year. Most often it's once a month. All right? This is still called the annual interest rate. Don't let that freak you out. You don't have to do anything complicated to that. You just plug the annual interest rate right there. You just got to remember to put in a divide by 12 right here. All right. So this is also called the principal. Sometimes that's an investment. But if it's an investment, you don't take $100 out every month. You would change the problem, if this is an investment, to be a plus right there. That's the only thing that changes. Notice this is a plus either way, because interest is always something that grows. There's no such thing as negative interest. Okay, so the only difference between a loan and an investment is that little sign right there. Now I can tell it's an investment. I started with 1,000 and I'm putting in $100 every year. What if I change this to divided by 12? Then I'm putting in $100 every month. That's pretty realistic. And you can figure out how much would you have after, let's say, 1,000 months, or that's a long time. 60 months is 5 years. That's a pretty typical period of time people talk about. Or 360 months is, let me think what that is. Yeah, I think I was wrong on this. Let me think, 12 months times, let's say, 10 years will be 120 for 10 years. So to get, yeah, that was right. 30 years would be 360. Why do we use 30 years a lot? Because almost everybody's mortgage on their house is a 30-year loan. That's the normal. They do offer bigger ones nowadays. Sometimes they have 40-year loans. But here's the sad part. It only drops your payment like a little bit. And now you have to pay it for 40 years instead of 30. But some people need that extra drop in their payment, even though it's only a little bit of a drop in payment. They need that because they can't afford it otherwise. So, all right. So that's just a reminder of what you need to do for your assignment, which is to do the evens on the homework that's posted for today. But we're going to do about a 20-minute little experiment to see if you can discover on your own how to find those end values, whether they be infinity or 0 or negative infinity or some number. The tricky ones to figure out are the numbers. And I think some of you can figure it out. All right, take the challenge. And that's all I have for the video for today.